4 billion years. That is how long Earth has survived out here. No shield, no backup. Just a rock spinning through a universe that does not know we exist. And most days, that is fine. But there are things out there that could end all of it. Not in a movie, in real physics, with real numbers, calculated by real scientists.
5 of them. One is a star that is already watching us. One has a date on NASA's calendar. And the last one would give us no warning at all. 0 seconds. We are counting down from 5. And number 1 is the reason some physicists say the universe is not as stable as it looks. Let's begin. Number 5. The star we depend on. The sun is not calm. It is a nuclear furnace. And sometimes it throws a tantrum. In 1859, a solar storm hit Earth. Telegraph wires caught fire. Operators were shocked by their own equipment. The northern lights were seen over the Caribbean. That was the Carrington event. And in 1859, it barely mattered. We had almost no electricity to lose. Today, that same storm would be a catastrophe. Power grids would collapse. Transformers take months to replace, and we do not keep spares. Satellites would die. No GPS. No banking.
Scientists estimate the damage at over $2 trillion, and years without power across entire continents. And here is the part nobody likes. We would get about 18 hours of warning. Solar physicists estimate a Carrington-level storm has roughly a 12% chance of hitting us in any given decade. Not in a million years. This decade. The sun does not need to explode to ruin us. It just needs one bad day. Number 4. The rock with a date. Most asteroids are harmless. They drift, they miss us, and nobody notices. BENNU is different. BENNU is about 500 meters wide, wider than the Empire State Building is tall. And NASA has been watching it for years. In 2020, a spacecraft called OSIRIS-REx flew out, touched BENNU's surface, and brought a piece of it home. Because BENNU is not just a science target, it is on a list. BENNU crosses Earth's orbit every 6 years. And on September 24th, 2182, it makes its closest approach. The odds of impact that day are about 1 in 2,700. That sounds small. It is also the highest risk on NASA's entire list. If it hit, the energy released would be around 1,200 megatons.
The largest nuclear weapon ever detonated. It would not end humanity, but it would darken the sky, drop global temperatures, and destroy an entire region in seconds. The strange part is not the danger. It is that we know the date. Number 3. The star that does not stop. We think of stars as fixed, beautiful, distant, permanently in place. They are not. Every star in the galaxy is moving, including ours. And some of them are moving towards us. Around 70,000 years ago, a small red star passed through the outer edge of our solar system. It is called Schultz's star. It came within 1 light year of the sun. Our ancestors were alive when it happened. It did no damage this time, because out at the edge of our solar system, there is a shell of frozen comets called the Oort cloud. Trillions of them, loosely held, barely attached to anything. When a star passes through, its gravity does not need to hit us. It just needs to nudge. And a nudge sends comets falling inward, towards the sun, towards the planets, towards us. Not one comet, a rain of them, lasting thousands of years. Astronomers have already identified a star called Gliese 710 moving in our direction. It will pass through the Oort cloud in roughly 1.3 million years. And when it does, the sky will change. Number 2. The 10-second execution. When a very massive star dies, it does not simply explode. It collapses. And as it collapses, it fires 2 beams of energy out from its poles. These are gamma-ray bursts. They are the most violent events in the universe since the Big Bang. In a few seconds, a single burst releases more energy than our sun will release in its entire 10 billion year lifetime. And they travel in a narrow beam, like a searchlight. If one of these beams pointed at Earth from within a few thousand light years, here is what would happen. The burst itself would last about 10 seconds. You would not feel it. You would not hear it. Nothing would look wrong. But in those 10 seconds, the gamma radiation would tear apart our ozone layer. Some models suggest half of it gone. And then the sun we have always trusted becomes the problem. Ultraviolet radiation floods the surface. Plankton dies first, then the food chain above it. Some scientists believe this already happened. The Ordovician extinction, 440 million years ago, wiped out around 85% of all species. One leading theory for the cause is a gamma-ray burst. There is no defense. There is no warning. The light that tells us it happened arrives at exactly the same moment as the damage. Number 1. The end that has no warning. Everything so far has been about Earth. This one is not. Empty space is not empty. It is filled with fields, invisible,
everywhere, holding steady. One of them is the Higgs field. It is the reason particles have mass. It is the reason matter holds together. Physicists assumed that field sat at its lowest possible energy, stable, permanent, finished. Then they measured the mass of the Higgs boson, and the numbers suggested something uncomfortable. Our universe may not be in its lowest state. It may be sitting in a dip, the deeper one below it. Physicists call this metastable, a ball resting in a small hollow near the edge of a cliff, stable until it is not. If anywhere in the universe that field slipped to its true lowest state, a bubble would form. Inside that bubble, the laws of physics would be different. Atoms could not exist. Chemistry could not exist. Nothing we are made of could exist. And that bubble would expand outward, the speed of light. Which means this: there is no warning, no approaching light, no sign in the sky. The edge of the bubble arrives at exactly the same instant as the information that it exists. One moment, everything is normal. The next moment, there is no moment. The good news, if you can call it that, is that the calculations suggest this is unlikely for a very long time, far longer than the current age of the universe. The bad news is that it could also have already started, somewhere out there, and we would have no way of knowing. So, there they are. 5 ways it ends. A star that has a bad day. A rock with a date on the calendar. A visitor that knocks comets loose. A beam of light that strips away the sky. And a bubble that rewrites physics itself. 4 of them we can see coming. 1 of them we cannot. But notice something. Every single one of these was discovered by people looking up. Nobody had to find them. We chose to. We built telescopes to watch the sun. We sent a spacecraft to touch an asteroid. We mapped the paths of stars that will not arrive for 1,000,000 years. A species that did not care would not know any of this. 1,000,000,000 years. And we are the first generation that can see what is coming. That is not a small thing. Next Sunday, we go the other way entirely. Not what could end us, but what is out there, waiting to be found. If you want to be here for that, subscribe. And if this made you look up tonight, leave a comment and tell me which one you would want to see coming.